Okay, so now that you know about ratios and proportions, it's time for you to learn about similar and congruent figures. First, we'll go over our 3 vocabulary terms, and then we'll work through our 2 examples. Let's take a look at our first term, similar figures. Similar figures are figures that have the same shape, but not necessarily the same size, whose corresponding sides are proportional, and whose corresponding angles are equal in measurement. Our second term is corresponding parts. In similar figures, the corresponding parts are the angles and the sides that have the same relative position. And our third vocabulary term, congruent figures. Congruent is a word you've been hearing since you were probably a 2nd grader for sure. Congruent figures are figures that have the same exact shape and the same exact side. And we're going to be using these terms while we work through our examples. Okay, let's take a look at number 1. Given that triangle ABC is similar, notice this similar sign, it looks like a tilde. Given that triangle ABC is similar to triangle XYZ, name the corresponding angles and the corresponding sides. So remember, the fact that these are similar means that their side lengths are proportional and that their angles are equal. So here's how we designate that we're talking about, we're naming an angle. It looks like a less than symbol, except the base is flat, almost like the base of this triangle. So first we're going to name the 3 angles of our first triangle. We have angle A, angle B, and angle C. And what we're going to do is use the same tilde symbol to show that it is similar. So when we look at this triangle and this triangle, we have to imagine that this second triangle is flipped so that we can name our corresponding parts. In this triangle ABC, angle A is similar to angle X. When figures are named, it makes this task a lot easier because their position in the name matches. So you notice here angle A is in the first position of triangle ABC, X is in the first position of XYZ, so that alone tells us that they are corresponding angles. Likewise, angle B, which is over here, is similar to angle Y in this triangle. And then angle C is similar to angle Z. Now that we've named our corresponding angles, it's time to name our corresponding sides. And the way that we indicate a side is to name the side, and I'm going to start with A, B, because I like to go in order. So we name it by its 2 endpoints, and then we put a straight line across, similar to the bar that you use when you have a repeating decimal. And again, we are going to use this tilde sign to show that it's similar. And again, the position in the title gives us the corresponding piece to the second figure. So side AB is similar to side XY. And then we'll just go clockwise. Side BC is similar to side YZ. Oh no, sorry. No, that's right. And then our last side is side CA. And that is similar to side ZX. And just to review that real quick, if you notice, AB is in the first and second position in the title of the triangle. XY are also in the same position. Next we have BC, they're the last 2. YZ, likewise the last 2. And then we have CA, which is our third and our first. And then ZX, third and first. So if you're given a title, I would go with this, especially if it's hard for you to to visualize the figures if they are flipped or has other kind of translation. Now, example 2 is a little different because we are going to be using some numbers and some math. Because we said that they are proportional, we are going to be able to see what the proportion is one side to the other. Given rectangle KLMN is similar to rectangle QRST, find the ratio of the lengths of corresponding sides KLMN to QRST. Now, I highlighted this and underlined the word to for a reason. I'm hoping that to see this reminds you of when we worked with ratios a couple of weeks ago. So when we set up our fractions, which you know are what ratios are, we have to remember to put the sides for KLMN in the numerator and QRST in the denominator because of the way that it is worded in the problem. So the first thing you're going to do when you have to find ratios or proportions is to identify your corresponding sides. And I did that piece already here. Since side MN in this rectangle has a measurement, I'm putting that first, side MN. And then what I did was I found the side in figure QRST that is similar to MN, and as you can see, it's side ST. So then our next step is to move from identifying the sides into putting them into a ratio. And remember, because this figure comes first, and the side MN goes in the numerator. So our next step is to fill in the side lengths. MN has a side length of 8 meters. Let me move over here. And side ST. Now, ST is not labeled, but remember, because they're rectangles, we know that opposing sides have the same measurement. So we know that side ST has a measurement of 6 meters. And then, of course, we always have to write it in simplest form, but because we're talking about a ratio, we have to keep it as a fraction, even if it means having it be an improper fraction. So the greatest common factor of 8 and 6 is 2. So when we divide 2 out of 8 and 6, we end up with 4 over 3. So the ratio of side MN to side ST is 4 to 3. And we're going to follow those same steps to find the proportion of sides, of the longer sides in this rectangle. So again, I chose the side that gave us the measurement already, KN, and that is similar to side QT in this, in this second figure. Next, I set it up into a fraction, which is a ratio. Now I need to fill in the values. The length of side KN is 20 meters, and the length of side QT is 15 meters. Then, of course, you simplify. The greatest common factor of 20 and 15 is 5. There are 4 5s in 20 and 3 in 15. And since they are proportional, we've proven it by showing that the ratio of each set of sides to the other is 4 to 3.